Hi, hello, welcome to Infinity Stella. Today's lead code problem is reverse linked list 2. Let's see the problem statement. Given the head of single linked list with two integers left and right. When left is less than or equal to right, reverse the node of the list from the position left to the position right and return the list. Reverse list. So I gave the list and they gave the left and right indexes. So whatever the between of two indexes we have to reverse. See, they gave the L equal to 2 and R equal to 4. So whatever between them we have to reverse it. So let's see how exactly works on the iPad screen. Okay. See, they gave linked list. Okay. They gave it is based upon the one based indexing, right? 1, 2, 3, 4, 5. So L equal to 2 and R equal to 4. So whatever in between we have to reverse it, right? So let me explain how we will do it. Okay, I'll take temp value which is pointing 1. Temp. I'll also take reference and reference 2, reference 3. I'll tell you why. Okay, when temp is on 1 and length is 1, right? I'm just taking the count or length and taking the temp to move forward whole list, right? So I'm taking length or size equal to 1. Okay, so size is less than or equal to L. Yes, it is right. The one index is less than the two index, right? So that is the reason I'm taking the value which is temp. Okay, so here it will store 1. Okay, then I'll move forward this. Here when size become 2 and it also becomes equal to 2. L equal to 2 and its size also becomes 2. So that is the reason will store that index as well. Okay, it is also temp, but it will store the index of 2. It is also temp, it moves forward till R equal the length or size which matches 4, which is right. When R equal to size, or else when size equal to R, then only store reference value whatever that present on the node. Okay, which is 4. So we need to break the bonds and reverse the list, right? Let's take ones 1, 2, 3, 4 and 5. So reference 1 is pointing to 1, reference 2 is pointing to 2 and reference 3 is pointing to 4. 3. Reference 3 is pointing to 4. Okay, so now we have to break the bonds, right? We have to break the connections or bonds here, right? So firstly let's do on 1 and 2. Okay, so I'll break the bonds on 1 and 2. Okay, then I'll also break the bonds here as well. But before I make before I make connections or bonds to disconnect, we have to store this reference as well, right? So I'm making reference 4 equal to reference 3 dot next, because when we reverse this old list now, when we reverse the whole list, whatever the last pointer of this, you have to attach this as well, right? So that is the purpose I'm making these connections or bonds to be break, and for that, whatever the elements present on the right, we have to store that as well, right? Reference to not to lose it. So that is the purpose of reference 4. Okay, so I'm making this bonds also break. Then I will reverse it whole thing. It will still pointing to reference 2, then it becomes 4 3 2, which is pointing to reference 2, and which is pointing to reference 3, and then 5, which is reference 4. Then we have to make the bonds, right? So we have to make the connections. So that is how exactly you are going to do this whole thing. Will take the time complexity of O of n and the space complexities of n. Sorry, space complexities of 1, because we are not doing any data structure here. So let's code on LeetCode. Okay, see, I'm taking reference 1, which is null, reference 2, which is also null, equal to null, and reference 3 equal to null. Okay, one second. Reference 1 equal to null, okay. Then I'm taking the temp, which is pointing to head, right? Then I will move the temp not equal to null, right? We also need size equal to 1. If size is less than left, then we have to point reference 1 equal to temp. If size equal to left, we have to store reference 2 also, right, equal to temp. Then if size equal to right, then we have to store reference 3 equal to temp. We have to increment the size as well as we have to move forward of temp dot next, right? Then once you having the references, you have to make fourth reference, which is nothing but storing the node of this 5. So that is the purpose I'm taking reference 4, reference 3 dot next, right? Then I have to break the bonds between 4 and 5, right? So reference 3 dot next is equal to null. Then once the bonds are broken, we have to reverse this. So reference 2 equal to reverse of reference to. Okay, we got this reference, we have to attach to this, right? But to some list, linked list, there may exist of one or not. Even there might be, they may ask like we have to reverse from 1 to 3. So that is the reason I'm checking if it is um, if reference 1 is null or not. Okay, if reference 1 is not equal to null only, then we'll attach reference dot next equal to reference of 2. Okay, else we'll make that as head equal to reference 2. Okay, then we have to know this pointer, right? As it is reversed, we have to know the pointer as well, right? While let's take this node equal to tail, consider as a tail, or equal to reference 2, while tail dot next. Why I'm not taking not next? Because of it shouldn't be null. I mean, if it is a null, then there's no point of doing it. So that is the purpose I'm taking it as a null. So I mean, whatever, see, this value shouldn't be null, right? So that is the purpose. If it is null, we couldn't able to attach it, right? So that is the reason I'm taking a tail dot next. So we are just moving the forward, tail dot next, tail equal to tail dot next. Okay, then tail dot next equal to reference 4. We have to return head. Let's run it. Okay, there is an error. If size equal to right. Okay, there is a spelling mistake here. Size, there is also, okay, we didn't code on reverse as well. So public static list node reverse of list node head, list node previous equal to null, list node I'm taking 3 pointers here, which is nothing but future, which is pointing to head, and as well as I'm taking current as well, which is pointing to head, while future is not equal to null, then future dot equal to, we are just moving forward that pointer, then whatever the current dot next is present, we have to make it as the previous to reverse the nodes, then we have to move forward. So current previous becomes the current, and current becomes the future, then we have to return previous. Yeah, it is accepted. Let's submit it. Yeah, it is done. Okay.